What would the doomsday of Earth look like? Carbon dioxide rises non-stop, global tension grows, promises remain unkept. War's end is nowhere in sight. Doomsday clock ticks closer to midnight. Humanity's future looks bleak. Not to be a downer, but climate and conflict issues are clear. Many wonder, is doomsday near? What's it like? A day after tomorrow scenario, or Dune and Mad Max desolation, or a Fallout nuclear aftermath? Our path is yet undecided. Scientists have simulated options, showing us possible futures. It's our choices to make after seeing the outcomes. How do we simulate the climate change? Simulating global climate is massive. 3 essentials are needed. First, deep climate and physicochemical understanding, meaning comprehensive atmospheric theory. Second, and most crucial, is securing enough data for planetary simulation. Data ranges from Earth's radius, rotation, ocean distribution, to solar radiation, down to surface conditions and topography. For example, Taiwan's central mountain range can influence Pacific typhoons and East Asia's climate. Furthermore, for a realistic Earth replication, ocean temperature profiles must be considered, along with biogeochemical reactions from vegetation, such as plant water absorption, storage, and evapotranspiration, altering atmospheric water vapor significantly. Lastly, with theory and data, a third crucial element for climate simulation is computing resources, or powerful supercomputers. We've spent an entire episode on how weather forecasting is done, noting top supercomputers are largely used for atmospheric research. This is not just due to the vast amount of data, but also because minor errors in parameters can cause a butterfly effect, significantly impacting weather forecasts days ahead. Therefore, meteorologists finely adjust parameters and calculate each set, greatly increasing computational load. Theory alone is hard to grasp, so let's illustrate how meteorologists simulate climate. Simulating just our familiar Earth isn't enough, with Dune Part 2 having just premiered. Let's see how meteorologists simulate Arrakis turning into a desert planet based on the novel. Could Earth also face a similar fate? How to simulate Dune's planet. Alexander Farnsworth from Bristol University, Sebastian Steiniger, and Michael Farnsworth from Sheffield University simulated and discussed Dune's Arrakis. In terms of theoretical models, he used a climate model for studying Earth's changes. Data was taken from the original novels and Dune Encyclopedia by US literature professor McNally. Key parameter including carbon dioxide at 350 ppm, about 80% of Earth's, and ozone levels 5,000 times Earth's at 0.5%. Note that ozone's greenhouse effect is 65 times that of carbon dioxide over 20 years, making Arrakis' climate distinctly different from Earth's. Finally, Alexander input detailed info like orbit, shape, and mountain ranges, including the dry, sealess land. The last step was the supercomputer. This desert planet is Dune's Arrakis. The simulation took over 3 weeks, with hundreds of thousands of calculations finally simulating Arrakis in 500 years. Why choose Arrakis in 500 years? Because initial values were just starting conditions. The planet needed time to adjust until the climate balanced out, a process called spin-up. Calculated seasons must have minimal variance year over year. Once the variance is negligible, the model is considered stable, marking a successful simulation. So, can Arrakis truly be habitable? The model's results are fascinating. In the first few simulation years, atmospheric moisture nearly vanished. Most water became groundwater. Once the climate stabilized, the equator and tropics could reach 45 degrees Celsius in summer and not drop below 15 degrees Celsius in winter. However, mid-latitudes and poles far from the equator could surprisingly soar to 70 degrees Celsius. The lowest at mid-latitudes could hit 40 degrees Celsius and 75 degrees C at the poles. High latitudes face extreme cold and even higher heat, making temperatures extremely extreme. This defies intuition as the equator receives the most solar radiation. The main reason is higher humidity at the poles, even leading to cloud coverage. Since water vapor is a greenhouse gas, it significantly warms these areas. In the original Dune novel, humans mainly reside in mid-high latitudes and high altitudes, presumably due to Earth-like climate conditions. The poles are the coolest areas. However, according to simulations, the tropics might be the most habitable on Arrakis, not the mid-latitudes. Scientists just love to nitpick science fiction. Moreover, Arrakis in the novel has no rain, nearly a dry planet. But climate model calculations show minimal rainfall in high-latitude summers and in mountains and plateaus. However, due to the extreme temperature differences mentioned, this rainfall doesn't form ice caps. With that said, if Elon Musk ever wants to buy property on Arrakis, remember not to buy at the poles, or the heating and cooling costs will explode. But supercomputers aren't for everyone. Using them for typhoon forecasts or Mars atmosphere makes sense. But simulating Dune, a fictional planet that only exists in sci-fi? PanSci once exclusively interviewed Dr. Farnsworth. Here's his explanation. I've been a massive fan of Frank Herbert's Dune since childhood due to the fantastical world he first envisioned many decades ago. To be able to look at it as a scientist was a fantastic experience and brought back that childhood wonder. So I hope this work equally inspires others to learn about how our climate works, how we should not take our planet for granted, and maybe even inspires the next generation of climate scientists. To him, simulating different planets under various conditions helps us understand our own planet better. Finally, if we can simulate climates of sci-fi planets, what about Earth? The Day After Tomorrow, or Mad Max, which is it? Will we need to build another Noah's Ark? Of course, it depends on our approach to climate change. As for the intensification and unpredictability of extreme weather due to climate change, no need for further reminders, that's reality. If Earth warms up completely, melting the polar ice caps, will we need another Noah's Ark? Kevin Costner's 1995 sci-fi classic Waterworld talks about polar ice melting due to global warming, leaving only the Himalayas above water. This, of course, is an exaggeration. Antarctica holds 26 million cubic kilometers of fresh water, about 91% of the world's ice volume. But with Earth's surface area at 510 million square kilometers, even if all ice melted, sea levels would rise at most by 70 meters. Flooding plains, yes, but not to the point of a dire water world. What if humanity waged devastating wars? What becomes of Earth? Mad Max, the series from 1979-2015, shows a world scarred by oil shortage, war, and ecological extinction, where humanity lives in desolation. A world after ecological disaster. How would such a devastated world look? A 1982 study used a global atmospheric model, indirectly simulating this scenario. It focused on how surface water vapor affects climate, with plants playing a key role in the water cycle, absorbing and then transpiring water, releasing it into the atmosphere. Clouds return it to the soil via rain, completing the cycle. Without plants, the water-to-air pathway is disrupted, affecting the cycle's process. Only a few areas would get vapor from the sea, leaving most regions with dry soil and air. According to this, July would bring high heat to many areas, with North America, Russia, and inland China seeing 40-45 degrees Celsius. Coastal areas might be slightly cooler. Eurasia, the American West, and Australia would have no rainfall, with chances of rain only at the equator and in highland areas. This makes Mad Max seem quite realistic. Next, consider another apocalyptic war scenario: total nuclear warfare. After a full nuclear war, what's left of our world? After the nuke is a popular question. Will we live in a Fallout Metro 2033, the strain scenario? First, a massive nuclear strike creates a devastating thermal blast, destroying everything within 10 kilometers, killing beings, Radioactive fallout then enters the atmosphere, reaching the stratosphere. Substances in the troposphere return to the ground with rain, causing nuclear contamination. Stratospheric materials lacking rain can't effectively be removed to the ground. Massive soot clouds will obscure the sky, leading to a nuclear winter. A 2019 study explored, assuming a US-Russia nuclear war with 4,000 warheads detonating. It launched 150 teragram of soot into the atmosphere, triggering nuclear winter. Soot could cool Earth for 10 years, with the coldest temps in the first year. Summers in North America, Eurasia could drop by 25-degree mark. Winters would bring sub-zero temps as far south as Mexico, India, Vietnam, and all of China. Temperature change is just the start. Plant growing seasons would drastically shorten. Well, shorten is an understatement. About 25 days left for northern hemisphere growth. Soot obscuring the northern skies is to blame, with tropospheric rain bringing soot down. An EGU report shows 150 teragram of soot entering the atmosphere would collapse summer monsoons and disrupt northern hemisphere winter circulation, eventually cooling Earth by 0.5 to 1.0 degrees C long term. This could leave 5 billion without food in the second year as agriculture collapses. Based on a global population of 6.7 billion, now surpassed by over 8 billion. So the 5 billion figure would definitely need revising. Indeed, nuclear war would spell the end for humanity. These are simulations of Earth's end scenarios. Climate simulation is complex, but it helps us understand global warming, planetary climates, even nuclear apocalypse. It allows humanity to prepare and choose actions beneficial for our future. Also, we'd like to ask, if Earth becomes uninhabitable one day, which planet would you prefer? A. Pandora, rich in resources, assuming humans are kind to natives. B. Tatooine, though a desert, might awaken the Force. C. I'd stay on Earth, collecting bottle caps, no worries. That's all for this episode. If you want more apocalyptic content, subscribe to PanSci channel, hit the bell, and join our channel membership. See you next time.